And the title of this talk is Artificial Intelligence Says Neil deGrasse Tyson Misunderstands Einstein Relativity. So this is Neil deGrasse Tyson. He's a science popularizer. I asked AI ChatGPT and it turns out he misunderstands Einstein's relativity. The defensible position of Neil deGrasse Tyson is he is trying to dumb it down, simplify Einstein's relativity for a general audience, but that dumbing down is really just distorting the subject and giving wrong impressions. I asked overall, did Neil deGrasse Tyson misunderstand Einstein's relativity? And ChatGPT said yes, but did get defensible about him, i.e. wanted to defend him. Tyson is a mainstream type of person, and these artificial intelligence want to defend that point of view. And so ChatGPT said yes, the overall answer is yes, but the precise defensible way to say it, as for me, is that Neil deGrasse Tyson misunderstands what Einstein's relativity commits us to metaphysically. So what we're talking about here is Tyson gets the metaphysics wrong, even though he understands how the theory works operationally and mathematically. The wording matters because it keeps the critique accurate and unassailable. That's my critique it's talking about. My critique is that he misunderstands the metaphysics. ChatGPT says, in short, he understands the physics as calculation. So Tyson is right about that bit. The bit he's getting wrong, this is Tyson, misrepresents the physics as metaphysics. So that's the bit he's getting wrong. He's messing up the metaphysics. And so ChatGPT says, so yes, your conclusion is correct. That's my conclusion. He misunderstands relativity in its deeper meaning, not in its equations. So it's trying to defend him here about the physics. Tyson has the physics correct, but he's getting the metaphysics messed up. And what these people do is they're getting metaphysics and physics messed up. So I got AI, artificial intelligence, ChatGPT, to look at a transcript of one of his videos and point out what he got wrong. And so this is the video I'm looking at from that address there.
That Einstein's relativity,
right?
More specifically, you learn this in special theory of relativity, where the faster you move,
right,
the slower time ticks for you,
right,
as others view it.
Relative to the observer.
Relative to the observer, correct. You don't know anything's happening.
Right.
Your clock still ticks as far, you still got your heartbeat, all of this. Okay, so this is not a physiological thing. It is an actual property of the fabric of space and time under those conditions.
Wow.
Okay?
That is fascinating.
It is. It's completely fascinating. It's completely. So I watch you fly by, and the faster you go, the slower time ticks for you. Okay?
But my time stays the same.
To you.
To me, right.
To you. So not only does speed do this, also the strength of a gravitational field will have the same effect on you. Oh. The stronger the gravitational field is, the slower time ticks for you. Oh. And that wasn't formulated until his general theory of relativity 10 years later. That took a lot more math and deeper insights into the universe.
But once again, it makes sense because you're dealing with the fabric of space-time.
It's the fabric of space-time, correct.
Wow, okay.
But initially when formulated, you're thinking it's just because you're moving.
Right.
But it's actually way deeper than that. And that's why that one, oh, by the way, his original special theory of relativity was not called that. The title of the research paper was On the Electrodynamics of Moving Bodies.
What?
Okay, that was the title. We would later call it the special theory of relativity because it was a special case of what would later then be called the general theory of relativity. While we're there, let me just slip this in. The GPS satellites orbit higher than like the space station and other things that are in what we call low Earth orbit.
Low Earth orbit.
They're in like MEO, the middle Earth orbit. There's LEO, MEO, and GEO.
Right.
Okay. If you have kids, maybe even name them that.
Yes. Leo, Mio, and Geo.
Low Earth orbit, middle Earth orbit, and geosynchronous geo orbit. Okay,
Right.
So the geosynchronous satellites are like middle orbit. That is far enough away from Earth's source of gravity for them to have a measurably different space-time condition.
Oh.
So that their clocks tick faster than our clocks on Earth's surface because they're farther away. And so remember I said the more intense the gravitational field is, the slower time ticks. So they're farther away. Their time ticks faster relative to us.
Wow.
But we get precise timings from geosynchronous satellites. So how does this work? We pre-correct the time signal from the GPS satellites to compensate for Einstein's general theory of relativity so that by the time the time reaches us, it's been properly corrected and it matters to us and our space-time continuum, not the one that's in middle Earth orbit.
Oh, my goodness.
So GPS couldn't work as accurately as it does.
However, wait a minute.
What?
I'm sorry, just for me. You would have to have a standard in order to pre-correct something.
You know the rate at which its time is speeding up because you can calculate what the gravitational field is up there.
There you go. Okay.
And once you calculate that, then you do and you say, oh my gosh, the formula works. Einstein was right.
Right.
All right. This is not just something on a high theory,
By the way,
hypothesized that may or may not be true. It is true.
I just want to be there when that phrase is uttered. Oh my God, Einstein was right.
Yeah, these aren't just cult heroes that we wish they were right.
Right.
These are real. This is real. Okay, this is the real universe we're talking about here. Okay, so now watch. Let's keep going faster and faster. Let's go half the speed of light, three-quarters the speed, 90% the speed of light, 99% the speed of light. Time is ticking slower and slower and slower. For you, you will watch the whole future history of the universe unfold in front of your eyes as fractions of a second go by for you. As you go 99, there's a formula for this, of course, but 99, 99.9, 99.99% the speed of light.
Because you're the observer of that. But
that.
for you, your time has slowed to the point where as you observe the things that are not moving at the speed of light, you see them
Speeding,
basically,
correct.
you see
Speeding
them
up.
unfold.
Correct.
Boom. God.
Correct.
That is insane.
And so I gave a transcript of that talk you just seen from Tyson to ChatGPT and asked it to comment on it. And it said, short answer, it was mostly correct at a popular science level, but several statements are sloppy, misleading, or technically wrong. I'll go through it carefully and separate what is correct, what is imprecise, and what is wrong or overstated. So ChatGPT goes through first what is essentially correct, and it points it out there. In special relativity, moving clocks run slower relative to clocks at rest in a given frame. Each observer experiences their own proper time normally, heartbeats and biology unchanged locally. Time dilation is not physiological, it is a property of space-time as modelled in special relativity. Then you have clocks deeper in a gravitational potential tick more slowly than clocks higher up. This effect was formalised in general relativity about 10 years after special relativity. And the other things which is essentially correct, as pointed out by ChatGPT, GPS requires relativistic corrections. GPS clocks are pre-corrected to account for relativistic effects. Without these corrections, GPS would accumulate errors of approximately 38 microseconds per day, causing kilometer scale position errors. The corrections are calculable from known orbital parameters and gravitational potential. Also, the title of Einstein's 1905 paper was correctly stated as on the electrodynamics of moving bodies, and also correctly stated that it was then later named special relativity. So ChatGPT then goes on to deal with what is imprecise or misleading. So quotes Tyson saying, "My time stays the same to me." And the problem with that is this is true locally, but the phrasing hides an important symmetry. Each inertial observer measures their own proper time normally, but each also judges the other's clock to run slow. Tyson presents it as if there is a single external viewpoint. And that is where, quote, "I watch you fly by," without explaining reciprocity. This omission is pathologically dangerous because it hides relativity of simultaneity, the twin paradox resolution, frame dependence of time comparisons. So what Tyson is really doing there is dumbing it down, and he's not going into all the details. Number 2, the fabric of space-time language. This is metaphorical, not literal. Space-time is a mathematical structure, not a physical fabric in the ordinary sense. Tyson presents the metaphor as ontologically real, which goes beyond what experiments strictly establish. This matters philosophically, even if calculations work. So Tyson is distorting things a bit there. Next is GPS orbit description. This part contains clear factual errors. GPS satellites are not geosynchronous. They are not GEO. They are medium Earth orbit, MEO, at approximately 20,200 kilometers altitude. Geosynchronous stroke GEO satellites are at approximately 35,786 kilometers. So the phrase the geosynchronous satellites are like middle orbit is simply wrong. I put that down just to be in a slip being made there. Next brings on to when Tyson said, "We pre-correct for general relativity." And ChatGPT brings it up like that. This is technically incomplete. GPS corrections include special relativity, such as satellite speed, implying clock slow down, and general relativity, where you take into account weaker gravity implies clock speed up. The net effect, clocks tick faster overall than are offset on the ground. Tyson mentions general relativity but does not clearly explain the competing special relativity effect, which is essential. So he's glossing over things there when he's talking about it. ChatGPT then goes on, what is overstated or philosophically loaded? He says Einstein was right as a blanket claim, and that is correct for saying that Einstein's equations work extraordinarily well. However, this does not uniquely prove Einstein's interpretation. So that's where we're getting on to the metaphysics bit. You've got the equations, but the metaphysics is dealing with the interpretation. and so it doesn't prove Einstein's interpretation of that mathematics. Next is the Lorentzian stroke preferred frame interpretations can reproduce or observe special relativity effects. GPS confirms relativistic formulas, not necessarily space-time ontology. So what Einstein's saying about the ontology is the nature of space and time, and that it does not being confirmed by GPS. And Tyson collapses empirical adequacy with metaphysical truth, and the step is not forced by the data, so he's misrepresenting what the GPS actually shows. Next is when Tyson says you will watch the whole future of the universe. ChatGPT says about that, this is a limit case extrapolation, practically unattainable due to infinite energy requirements, acceleration constraints, causality, and horizon issues. As a thought experiment, it's fine. As a physical claim, it's highly idealized. So what he's doing is he's dealing with a thought experiment there. He's not actually dealing with physics, and he's not making it explicitly clear that he's dealing with metaphysics there, not an actual physics. So ChatGPT says, is the transcript correct? In the transcript I gave it about what Tyson was saying. And so it says, numerically and operationally, mostly yes. So he's mostly correct on that issue. But on conceptually, it's simplified and occasionally misleading. And that's where it's getting dumbed down. He's dumbing it down. Tyson dumbs it down, and by dumbing things down, he is distorting it. And next issue is factually. GPS orbit description is wrong, so he's making a mistake with GPS. Next is philosophically, he's overconfident about interpretation, so he's not pointing out there are different philosophical interpretations involved. So he's dumbing it down once again there. So that is the end, thank you, of this talk. And what Tyson does is the same as what most popularizers of science do when they talk about relativity. They dumb things down, and that results in it being distorted and giving the wrong impression about relativity. The main issue is they're not pointing out the difference between when they're talking physics and when they're talking metaphysics. And they seem to be getting the two things confused together. There's metaphysics and there's physics, and they're getting their metaphysics mixed up with their physics. And they all seem to be doing that.